Section 4.1 of AP Precalculus, I must be insane. We're talking about parametric equations. What are those, you ask? Well, basically, you pick some t values, and from the t's that you pick, you plug them into these guys and get an x and get a y, and you have points that you can plot. So let's do that. Let's pick some t values. Okay, and then our x value is going to be whatever t is, so that's nice. And our y value is going to be t squared over 4. And so we get some points that we can plot. Okay? So let's pick -4, -3, -2, -1, 0, 1, 2, 3, 4. Let's go with that. If x is t, then x is all of these. So -4, -3, -2, -1, 0, 1, 2, 3, 4. All right, let's do some mental math. If t is -4, so then -4 squared is 16. 16 over 4 is regular 4. -3 squared is 9. 9 over 4. -2 squared is 4. 4 over 4 is 1. -1 squared is 1. 1 over 4. 0 squared is 0 over 4 is 0. 1 squared over 4 is 1 over 4. Oh, I see what's happening. 2 squared is 4 over 4, which is 1. 3 squared is 9 over 4. And 4 squared is 16. 16 over 4. Now, is 4. Now, what we usually do with parametric equations is we not only plot the points, but we also plot the direction in which these points are headed. And the direction that you choose is always with the increasing t. So these are the points that I have. And I'm not going to write all these out because that would take too long. But if I have an x value of -4 and a y value of 4, I get -4, 4. And then I would get -3, 9 over 4, and so on and so forth. So -4, 4 lives here. And I will say that that's when t was -4. Okay. -3, 9 over 4 is like 2.25. So -3, 2.25 is when t was -3. When t was -2, I get -2, 1 lives right here. So t is -2. When t is -1, I got -1 and then a quarter. So that's when t was -1. When t was 0, I get the origin. So t is 0. And then we go back up. T is 1. T is 2 was 1. T was 3 was 2.25. So right there is when t was 3. And when t was 4, we had 4. Now, if I wanted to go one step further, since I have the space, if t was 5, I would have 5 and 25 over 4. So why don't I include that? 25 over 4 is 6 and a quarter. So 5 and 6 and a quarter. That's when t is 5. So similarly, t is -5 is going to be the same thing. And we draw ourselves a nice little parabola. Yeah. Now also, we include the direction. So I'm going to put arrows pointing this way a couple times, arrows pointing this way a couple times. Yeah, there you have it. That's how you graph a parametric equation. Fun stuff. Sketch the curve for the pair of parametric equations. X is 5 sine t and y is 4 cos t. This isn't my first parametric equation video. If you saw the first one, this is how we set up the first one. We're going to set up this guy just like it. We're going to pick some t values. And when we pick our t values, x is going to equal 5 sine t, and then y is going to equal 4 cos t. What we do by doing this is whatever t value we choose, we get an x, we get a y, and that gives us some coordinates that we can draw out. So what I'm going to do is I'm going to pick basically every quarter of a pi from 0 to 2 pi. So I'll choose 0, I'll choose pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. And I don't need to do 2 pi because 2 pi is just 0. All right. Let's math. 5 sine 0 is the same as 5 times 0, which is 0. 5 sine pi over 4 is the same as 5. So sine pi over 4 is root 2 over 2. So 5 root 2 over 2. Okay, we'll deal with that when we have to deal with that. 5 sine 5 sine, I did it again. Pi over 2 is 5 times 1, which is 5. 5 sine 3 pi over 4 is going to be 5 root 2 over 2 again. 5 sine pi is 0, so u becomes 0. 5 sine 5 pi over 4, that's negative root 2 over 2, so negative 5 root 2 over 2. 5 sine 3 pi over 2 is negative 1, so negative 5. And then last but not least, 5 sine 7 pi over 4 is going to be negative 5 root 2 over 2. All right, fun. Now let's do the cosines. Let's do the y values. You get 4 cos 0, which is 4 times 1, which is 4. 4 cos pi over 4. Cosine pi over 4 is root 2 over 2. So 4 times root 2 over 2 is 2 root 2, because things simplify out. 4 cos pi over 2. Cosine of pi over 2 is 0, so you're 0. 4 cos 3 pi over 4 is going to be negative root 2 over 2, so negative 2 root 2. 4 cos pi is going to be 4 times negative 1, so negative 4. 4 cos 5 pi over 4 is going to be 4 times negative root 2 over 2, so negative 2 root 2. 4 cos 3 pi over 2. 3 pi over 2 is 0, so 0. And then last but not least, 4 cos 7 pi over 4. Cosine of 7 pi over 4 is root 2 over 2, so 4 times root 2 over 2 is 2 root 2. All right. So I have a point of 0, 4. So when t begins, 0, 4, t is 0. This is where it gets interesting. Root 2 over 2 is like 0.7-ish, I believe. Root 2 over 2 is like 0.7. So 5 root 2 over 2 is like 3.5. So 2 root 2 is going to be like 3.5 again-ish. So I'm looking at, somewhere over here. Something like this, maybe. Something like that. And that's when t is pi over 4. 5, 0 is lovely. I can handle that. That's when t was pi over 2. And as you can see, we're working our way around. So let me try to recreate this the best that I can. That's when t is 3 pi over 4. Okay, when we're at pi, we're at 0, -4, so that's noish. Then we get -5 root 2 over 2, -2 root 2 over 2, 2 over 2, 2 over 2, 2, 2. You are going to look like this. And that's t equals 5 pi over 2. Then we have 3 pi over 2 is -5, 0. T is 3 pi over 2. And then you kind of complete out this ellipse-looking thing that lives like right around here. And that's when t is 7 pi over 4. So dot, 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 ellipse, 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 dot, 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 dot. And then we'll go this way, this way, this way, because that's when t is increasing. Look at that. So ellipses look like this is when you have like different numbers in front of sine and cosine. That's an ellipse. I wonder what would happen if you had the same number in front of sine and cosine. Circles, no spoiler alerts, it's just a circle. It's a circle. Well, there you go, ellipse. Write the pair of parametric equations in rectangular form. Well, rectangular form is y equals stuff. So what I really need to do is I need to replace t with x's. Well, how do I do that? Take this guy and solve it for t. So if I have x equals -2t minus 3, my first step is to add 3, cross you out, these don't combine. So x plus 3 equals -2t. Divide everything by -2, divide everything by -2, divide everything by -2. And now t, and I'll write this out a little bit prettier, is going to be -1/2 x minus 3 over 2. So to make it rectangular, I'm going to replace every t with that guy right there. So a little bit of foiling is going to happen, but that's all right. We have fun here. Y equals 2 times -1/2 x minus 3 over 2. It's going to be squared, so why don't I just do the FOIL thing while I'm at it? Plus 2 times -1/2 x minus 3 over 2 minus 5 over 2. Okay, let's FOIL this out. So 2 is just living. Okay. -1/2 times -1/2 is +1/4 x squared. Okay. Negative times a negative is a positive. Okay. 1/2 times 3/2 is 3/4. So plus 3/4, that's going to be the same. So plus 3/4 is 3/2. So plus 3/2 x. And then u are going to become plus 9/4. So let's scooch this over. So that's minus x. That's minus 3 minus 5 over 2. All right. You're going to equal 1/2 an x squared plus 3x plus 9 over 2 minus x. These guys do combine to make, let me see, u would be 6 over 2, so -11 over 2. Okay. Nothing happens with 1/2 x squared. 3x minus x is 2x. and you become 9 over 2 minus 11 over 2 is negative 2 over 2, or minus 1. So there you go. That's what it is. Y equals that. Not the prettiest thing in the world, not the most fun in the world, but we did it. If a particle moves along a curve described by the parametric equations x equals cos t and y equals sine 2t, what is the period of its motion? Well, before I go crazy, the period of this guy is 2 pi, and the period of this guy is regular pi. So what's going to happen is I'm going to have some sort of picture where it's going to take 2 pi to complete this and pi to complete the other parts. So the x values, whatever that might be, is going to take 2 pi to complete. All right, so by the time I make it all the way around, t is going to equal 0 and also 2 pi. It doesn't matter how fast this guy goes around. This guy is going to just repeat the cycle 2 times by the time it takes that one. So what you do is the period of a parametric equation is determined by the longer period. So since the longer period is 2 pi, my period is going to be 2 pi for this one. Kind of tricky. For the parametric equations, x equals 2 cos t and y equals sine t, what is the range of the resulting graph? Well, the range has to do with the y values. Okay, now with the y values, what I do, and when I normally graph these guys, I pick a t, and then I pick, my x values and my y values and blah, 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 and I have 0 and I have pi over 4, and I work my way down here. But common sense tells me that my range is going to be the largest number I get here. Well, the largest number I'm going to get is whatever I plug in, sine of whatever that's going to be, is going to be 1. So somewhere here, who cares what happens with t? Somewhere here, my largest y value is going to be 1, and my smallest y value is going to be negative 1. Okay, similarly over here, not that it matters, my largest x value is going to be 2, and my largest x value is going to be negative 2. So I know I'm going to have an ellipse that probably looks something like this. But what's most important is my range. And my range is going to peak out at 1 and bottom out at negative 1, which is going to be u. So yeah, that's and we see that this is an ellipse. I've done problems like this where we graphed an ellipse. We did the full-blown thing. But based off of the behavior of the graph that we did back in the day, we now know what this is going to look like without doing too much, and it's going to look a little something like this. Ooh, a challenge. A soccer ball is kicked across a field at an angle of 30 degrees. We'll change that. With an initial speed of 16 meters per second. Write a set of parametric equations for the motion of the soccer ball. So usually when you deal with the parametric equations types problems and you're dealing with shooting or firing or throwing something in the air at a specific angle, we are given 2 formulas to use. And of course, this is parametric, so x equals and y equals. The x equals is going to be the initial velocity, which we'll call v sub 0, times cosine of the angle that we're going to use, all of that multiplied to t. Okay, that's going to be the x function. The y function is going to be given to us as negative 1/2 of gravity, and we'll have a specific gravity number for this one because this one's in meters and not in feet. Thanks, America. Times t squared plus, very similar to this, but with sine. So the initial velocity, sine theta t, and then plus the height in which you're starting things off at. Okay, so basically what we need to do is we need to look at all this information and see what we're starting out with. Now, the initial velocity, that v sub o, is going to be 16 meters per second. The angle of 30 degrees, 30 degrees simply isn't going to cut it. So we're going to turn 30 degrees into pi over 6. like so. What else? What else? What else? The G that we're going to use. Now, there's two G's usually that we're going to use. One for feet, one for meters. If you're dealing with meters, the G that you're going to use is going to be 9.8. Okay, if it was feet, it would be 32. But since this is meters, 9.8. And we have, I think, everything we need to plug in. Oh, no, the initial height. The initial height is kicked across the field at an angle. I'm assuming that you're kicking the ball off of the ground, so we'll say height is 0. All right, let's plug stuff in. X is going to equal the initial speed, which is 16, cos pi over 6. We'll deal with that in a minute, times t. Okay, don't know why I switched colors, but I did. Y equals negative 1/2 g, which is 9.8. T squared is still t squared, plus the initial speed of 16 sine pi over 6. Close that, plus nothing, so we'll leave that as plus nothing. So cleaning this up a little bit, 16 cos pi over 6 is going to be root 3 over 2t. And then y is going to be negative 1/2, so we'll do negative 4.9 t squared. I think that looks pretty good. Plus 16 sine of pi over 6 is 1/2. And I forgot t, so we don't want to forget t. Okay, it's as if we're going to England and having that specific time of the day, tea time. So cleaning this up, and probably the last thing we're going to have to do for both of these. 16 over 2 is 8, so we got 8 root 3t. Y is going to equal negative 4.9 t squared, and half of 16 is 8 last time I checked, so we got plus 8t. So, yeah, these are not the most pleasant problems in the world. I can't imagine having to memorize this information right here for like a test, but that's what you use, and just keep in mind that you use 32 if we're talking about feet. But we ate. The position of a particle at time t is given by the parametric equations x equals sine t and y equals cos t. Ooh, a circle. What is the maximum distance that the particle travels from the origin? Well, if this is a circle, then it would make sense that the maximum distance is going to be the radius of that circle. Look at me drawing an absolute perfect circle. Do you like it? You shouldn't. It's awful. So that would be the radius. Well, how do you find the radius of a circle? Well, r squared is going to equal x squared plus y squared. So in this case, r squared is going to equal x squared, which is sine squared. Oh, sine squared t. And y squared is going to be cos squared t. Now, wouldn't you know it? I'm pretty sure I know exactly what that is. That is a Pythagorean theorem identity. So sine squared plus cos squared is 1. Square root 1, don't worry about the plus or minus because we're in real world terms. R is 1. So the answer is 1. A particle moves along the parametric curve described by x equals cos t and y equals sine t. What is the average rate of change of y with respect to x over the interval pi over 4 is less than or equal to t is less than or equal to pi over 2? Now, usually when we think average rate of change, we whip out this formula, the formula that we've been using since good old Unit 1, way back in the day. And you're like, let's find out what A and B are, which so far nothing's changed, and plug it into the formula. Well, here's the issue with the formula. We've got two the formulas. So we can't use this formula right here. What we're going to do is we're going to go back to the old school definition of what average rate of change means. And average rate of change is the same exact thing as slope. Slope, which is the change of y over the change of x. So what we're going to do is we're going to use that concept to figure out the changes of y over the changes of x. In other words, y of b minus y of a over b attached to x, so x of b minus x of a. And now we just kind of plug stuff in and go. Okay, y of b would be sine of pi over 2, so sine of pi over 2, minus y of a is going to be sine of pi over 4, so sine of pi over 4, over x of b, which is going to be cosine of pi over 2, minus cosine of pi over 4. Sine of pi over 2 is 1, minus sine of pi over 4 is root 2 over 2, all over. Cosine of pi over 2 is nothing, minus cosine of pi over 4 is also root 2 over 2. All right, so let's combine these two guys on the top. Let's turn 1 into 2 over 2 minus root 2 over 2 all over negative root 2 over 2. Lots of 2's. These guys combine to make 2 minus root 2 over negative root 2 over 2. Let's get rid of that fraction on the bottom by multiplying the top and the bottom by 2 over root 2. Don't forget the negative. So multiply the top and the bottom by negative 2 over root 2. Cross, cross. These guys can cancel out. That gets me 2 minus root 2 over root 2 with a big negative out in front. Multiply the top and the bottom by root 2 over root 2. Okay. So that becomes 2 on the bottom. Distribute that. 2 root 2 minus root 2 times root 2 is regular 2. Don't forget the negative out in front. There's a 2 in common with everything, so if I divide everything or both of these by 2, I am left with negative root 2 minus 1, because that negative is still out there, which changes that to negative root 2 plus 1. Kind of a gross problem. But we did it. Which of the following parametric equations represents a line? Well, we have 4 options here, and it's pretty obvious, but let's make sure we understand the other ones. What you do is you select t's, you plug them into these guys, and whatever numbers you get or whatever x and y values, coordinates that you get. I'm going to pretend that a is not there because that's the answer. If you look at b, b is a circle. As you plug in t values, you're going to create a circle that looks something like this going in that direction. Okay, that's what b is going to look like. For c, you would pick values that, if I were to pick 0, I'd get 0, 0. Easy. If I were to pick 1, I'd get 1, 1. That looks pretty linear so far. But once I start picking 2, x grows, but y grows a little bit faster. So then all of a sudden things change. I start out with 0, 0, and then 1, 1. But when I pick 2 for t, I get 4, and then 8. So this is going, and by the way, if I pick negative t values, the same thing's going to happen. So you're going to end up with a parabola, okay, where as the x values increase fast, the y values increase faster. Okay, so that's what you're going to get for C. D, you have square root and square root, and what you're going to get there is going to appear to be linear. But here's the issue. By the way, so if I were to pick like the square root of 1, or if I were to pick, 0, I'd start out with 0, 0. And then if I were to pick 1, I'd get 1, 1. And let's pick friendly numbers like 4, I'd get 2, 2. And you would be like, okay, well, dummy, as you pick more numbers, this is a line. In fact, this is a perfectly straight line. All right, Pick -1. See what happens. Oh, you can't plug in -1 because the square root of -1 is impossible? Okay, so it's not a line. A line is defined by something that creates a linear function that goes on forever and ever and ever. D doesn't do that, C doesn't do that, B doesn't do that. Basically, what you're looking at here is if x is t, I can rewrite this guy as y equals 2x plus 3 because t and x are the same thing. Last time I checked, that's a line because it's slope-intercept form. So my answer is going to be A. Consider the equation x squared plus y squared equals 25. Create a table showing the corresponding x and y values when x takes on the values -5, -4, -3, 0, 3, and 4. So this is what I'm going to do. Before I create my table, what they're basically saying is, hey, make a table, plug in these numbers for x, what y's do you get? So maybe I should take this guy and solve it for y. So let me write it over here. X squared plus y squared equals 25. In order to solve for y, the first thing I'm going to do is I'm going to subtract everything by x squared. So subtract everything by x squared, you get that. So y squared equals 25 minus x squared. Now, I'm going to take the square root of everything. Whenever you take the square root to solve an equation, you have to include the plus or minus symbol. So what we're going to get is y equals positive or negative 25 minus x squared. Now, why do I care about the positive or negative? Well, there's no restrictions here saying that I only care about positives or I only care about negatives. And again, whenever I solve an equation for y, and the way I have to solve is by taking the square root, you have to include the plus or negative symbol. So now I can make myself a little table of x and y values. Okay, so the x and y values they want me to use are -5, -4, -3, 0, 3, and 4. Why they chose those, I have no idea. Thanks, ChatGPT, for creating this problem. If I plug in -5, okay, if I plug in -5, I would get -5 squared, which is +5. So let me actually show the math for just the first one so you can see the math being done. Okay, let me just show the math for one of them. What color didn't I use? Red. So plus or negative, the square root of 25 minus -5 squared. -5 squared becomes +5. So we now know that everything that we plug in is going to become positive. So it's going to become -5 squared is 25. So positive or negative, the square root of 0, which is positive, or -0, which is just 0. Okay, so what's probably going to happen with these is I'm going to take that number, plug it in, square it. It's going to become positive no matter what. Do a little bit of math and plus or minus it. Okay, so if I plug in -4, -4 in here becomes 16. 25 minus 16 is 9. Positive or negative, square root of 9 is going to be positive and -3. If I were to plug in -3, -3 squared becomes 9. So 25 minus 9 is 16. Positive or negative square root of 16 is positive and -4. If I plug in 0, I get 25 minus 0. So positive negative square root of 25 is positive -5. If I plug in 3, 25 minus 9 is 16. Positive or negative, we get this again. And I know what's going to happen here. If I plug in 4, I get 16. So 25 minus 16 is 9. Positive or negative square root of 9 is positive or -3. So for x values, I get multiple y values. Now, graphically, what that gets us is, I pick x is -5, I get something. -4, I get 2 things. -3, I get 2 things. So what's happening is we're creating some type of, circular pattern. Maybe it's a circle, maybe it's not. It's a circle. But that's what we're going to get. And as I kind of keep this process going, if I plug in 0, I know my picture's not that great, but, I get obviously 2 things. So we're going to get ourselves some type of circular looking shape because it is a circle. Given the equation x cubed plus y cubed equals 27, solve for y in terms of x. So I have to get y all by itself. The first thing I'm going to do is subtract x cubed from both sides. Cross u out. Y cubed now equals 27 minus x cubed. In order to get y all by itself, we take the cube root of both sides. So cube root. Now, unlike square root, when you take the cube root, you do not attach a plus or minus. Okay, no positive or negative symbols here. So my final answer in the end is just this, the cube root of 27 minus x to the third power. And if you're like, can I simplify that? Nope. You're like, but they're both cubes. Nope, I'm subtracting. Can't simplify it. Can't do it. Don't even try. Investigate any asymptotes present in the curve defined by xy minus x squared equals 4. All right, well, I know what asymptotes look like, so why don't I graph this guy out? I've got xy, not graph it out, I'm just going to write it out. Xy minus x squared equals 4. I'm going to solve for y, so let's add x squared, u cross out. The guys on the right side don't combine, so that leaves me with xy equals 4 plus x squared. Divide everything by x. And y is now equal to 4 plus x squared over x. Now, we're going to have 2 asymptotes here. Okay, asymptote number 1 is a vertical asymptote at 0. Any number that makes the denominator equal to 0 is going to give us a vertical asymptote as long as it's not repeated somewhere in the numerator. Okay, so normally if you remember Unit 1, we would factor out everything. Well, you can't factor out the top because it's not factorable. And this is already factored on the bottom. So we have a vertical asymptote at x equals 0. Now, before we say we're done, we're not. Investigate any asymptotes. Well, you might remember from Unit 1 that if your degree in the numerator is 1 higher than your degree in the denominator, you have what's called a slant asymptote, which means no horizontal asymptotes. The way you find a slant asymptote is you use polynomial long division. So x divided by, write this in order, x squared plus 0x plus 4, and then we do a little bit of division. Okay, x times what is x squared? X times x is x squared. Take that x, multiply it to that x, and maybe we'll add a plus 0 there just to make it look better. X times x is x squared. X times 0 is 0, so plus 0x. Okay, subtract the entire row, which means subtract that. You get nothing, 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 nothing. Drop down the 4, nothing. So you might be like, oh, there's a remainder. We don't care about the remainder. Basically, when you divide x from 4 plus x squared, you get x, which means we have a slant asymptote at exactly y equals x, which is a perfect diagonal going through the origin. So the asymptotes that we end up with, this guy right here, given to us just like that, are a vertical asymptote at x equals 0 because it makes u undefined, and a slant asymptote at y equals x because we have a degree of 1 higher than down here, and we did polynomial long division, got just x, don't care about the remainder, so we say slant asymptote at the equation y equals x. Wasn't that fun? What is the equation of the circle with its center at the origin and a radius of the square root of 10? Well, the equation of a circle in general is given to us as x squared plus y squared equals r squared. Well, it tells us right here that the radius r is the square root of 10. So why don't I just take the square root of 10 and replace r with that? So r is now equal to the square root of 10 squared. Last time I checked, when you square a square root, they cancel each other out. So we're left with x squared plus y squared equals 10. The answer is A. Thanks for watching. Hope this helps. Graph x squared over 9 minus y squared over 25. Now, this is a conic section, and there's going to be three main types that you're going to graph. Two of them are going to look like this, where you have an x squared over a number and a y squared over a number. But the key thing here is we have a minus in between, and that tells us that this is a hyperbola. Now, a hyperbola in this function, or in this form rather, where x squared subtracting the y squared is going to look like this. I'm going to compare it to this. X squared over a squared minus y squared over b squared equals 1. Now, this is about as basic as it gets. The fact that it equals 1 makes life a whole lot easier. If it didn't equal 1, or if they didn't look like this, I'd have some work to do, but that's going to be for a later unit. When you have the x squared minus the y squared, this is going to be called the horizontal hyperbola, and we'll see what that looks like graphed. When given this information, you are going to have vertices that live at plus or minus a 0. You are going to have what's called co-vertices, we'll explain what that is in a second, at 0 plus or minus b. We're not going to worry about foci when graphing these things. I'm not going to lose any sleep over it. But what I am going to do is I'm going to write out the slant asymptotes, which is found by using the equation y equals plus or minus b over ax. All right, now let's find out what my b and what my a are. Okay, again, the original function is given to us as x squared over a squared. So if a squared is 9, taking the square root of these makes a 3. So my vertices are going to be positive or negative 3, 0. Similarly, this is going to be my b squared because it's underneath y squared. So if b squared is 25, then b is going to be 5. So that gives me co-vertices at 0 plus or minus 5. Now that I know what my a and what my b are, that gives me slant asymptotes at y equals plus or minus b over a, which is 5 over 3x. 5 over 3x. 5 over 3x. All right, vertices at negative 3, 0, boop, and 3, 0, boop. Co-vertices at 0, 5, boop, 0, negative 5, boop. Now, the co-vertices when graphing really isn't that important, but what it does is it helps me develop my slant asymptotes, and I can kind of create a box that will help me draw the path that my hyperbolic function is going to go through. Okay, I said what my slant asymptotes were. They're the equations 5/3 x and negative 5/3 x. So up 5 over 3 is going to look like this. So my box over there is kind of helpful. And the slant asymptotes guide what the behavior of my hyperbola is going to do as I graph them. Okay, it's basically just a guide. All right, now on to the graphing part, which is the fun part. Okay, when I have these guys, my hyperbola is going to go through the vertices and kind of follow along this path right here. So I'm going to try to draw you going along this path, and I'm going to try to draw you going along this path, and I'm going to try to draw you going along this path. That looks bad. And I'm going to try to draw you going along this path. That looks better. But the purple guy is my hyperbola. Okay, so it's basically a hyperbola is basically like two parabolas opposite of each other facing away from each other. But that's what this guy looks like, given the fact that we had the x squared minus the y squared. We had the sideways hyperbolas. If it was flipped around, it would be like that. But yeah, fun stuff. Graph y squared over 16 minus parentheses x plus 4 close parentheses squared equals 1. The heck is this, you are asking? I'll tell you what the heck this is. This is a conic section with a subtraction in the middle, and you have a y squared and an x blah, blah, blah squared. Whenever you have a y squared over stuff minus x blah, blah, blah squared minus or over stuff, and I'll put it over 1, equals 1, you have yourself a hyperbola in this form. Y minus k squared over a squared minus x minus h over squared over b squared equals 1. Now, the fact that this equals 1 is terrific news. Okay? Basically, what I have to do now is I have to compare this guy to this guy and label a few things. Now, keep in mind, this is a hyperbola because of the minus in between. If it was a plus, it'd be an ellipse. This is a y squared first, so I'm using this version of the formula, which changes things, okay? I did a problem where it was x squared first, and the hyperbola had sideways parabola-looking things. This will have uppy-downy parabola-looking things. So we're looking at a transverse axis that's parallel to the y-axis. That's good news. We're looking at a center being at hk, okay? We are looking at vertices located at H and then K plus or minus A. So we'll figure that out in a minute. We're looking at co-vertices that are given to you as H plus or minus B, K. And we're looking at slant asymptotes, which, you know, I'm not going to go crazy trying to graph because if I remember, these ones aren't pretty. Slant asymptotes live at y equals plus or minus a over b times the quantity x minus h outside plus k. All right, so let's label what we can label. Let's compare what we can compare. Y minus k up here with just a y. What does that mean? That means k is 0. Okay, because it would be y minus k in parentheses, so y minus 0 in parentheses, and so k is 0. If a squared is 16, then a is 4 because you just square root everything. Now we have minus x minus k, or x minus h equals x plus 4. Does that mean h is 4? Nope, that means h is negative 4. Do be careful, do be careful. B squared, when I square root everything, is going to give me a b of 1. Okay, so everything is labeled, everything is labeled, everything is labeled. My vertices, well, let's do the center first. My center is going to be hk, which is going to be negative 4, 0. My vertices is going to be hk plus a and k minus a, so that's going to give me 2 points. Let me write them out. H is still h, though, and h is negative 4, so negative 4 and negative 4. K plus a is 0 plus 4. K minus a is 0 minus 4. So those are my vertices. My co-vertices are going to be h plus b. So again, 2 points. So let me write them out. 2 points. H plus b is negative 4 plus 1, which is negative 3. K is 0. H minus b is going to be negative 4 minus 1, which is negative 5. And k is 0. My slant asymptote is going to be, slant asymptotes, is going to be the equation plus or minus a over b, which is 4 over 1, so 4, times the equation x minus h, so x minus negative 4, so x plus 4, close it, and then plus k, which is plus nothing. So if I really wanted to write both of these out, it would be positive 4 times x, positive 4 times positive 4, and the other one would be negative 4 times x and negative 4 times negative 4. Now, obviously, looking at those numbers, I'm not going to be able to graph them, which makes the vertices, my co-vertices, much more important than my slant asymptotes. Okay, the center is negative 4, 0. There's my center. My my regular vertices are going to be negative 4, 4, and negative 4, negative 4. So that's where my hyperbolas are going to open up and down, but the width of these guys are all dependent on the co-vertices. So we're going to have skinny ones. Co-vertices are negative 3, 0 and negative 5, 0. So negative 3, 0 and negative 5, 0. That allows me to draw my box. Okay. Now, the diagonals of my box would be my slant asymptotes. And as you can see from the x or the y intercepts of my slant asymptotes, drawing my slant asymptotes are not going to be fun. So I'm basically just going to draw, the dashed line representing the skinniness of my hyperbolas. The skinniness of my hyperbolas. Right there, those are my dotted lines. And my hyperbolas go through the vertices right here, going up and going down. So I'll draw that out. Oof. So there you have it, a hyperbola where the center is not 0, 0. Gross, but fun. Graph, holy cow, x squared plus 9y squared plus 6x minus 90y plus 225. This is a conic section. And you're like, no, it's not. This is just a really big problem. No, it's a conic section. What we have to do is we have to group these x's, we have to group these y's, and make it look like x blah, blah, blah squared over a number plus or minus y blah, blah, blah squared over a number equals 1. We have to make it look that way. So this is how you do it. You're going to take your x values, you're going to group them together on the left. X squared plus 6x, group them together on the left. You're going to take your y values, you're going to do the same and group them together on the left. So 9y squared minus 90y, and you're going to subtract the remaining constant from both sides, so equals negative 225. Now, the process that you're going to do for both x and y is a process called completing the square. What you do is you first off make sure there's nothing in front of x squared, thank goodness. You take half of the number in front of 6, okay? Take half of the number in front of 6. You're going to square that and add that to both sides. So half the number in front of 6, or in front of x, is 6, so half of that is 3. Square that, you're going to add 9 to both sides. What that allows you to do is now we can factor that out. 2x plus 3 squared. Okay, good news. Here's the thing, though, with red, can't do that quite yet, but what I'm going to do is I'm going to factor out the 9. So plus 9. Y squared minus 10y, and I'm going to set that equal to negative 216. Okay. Right now, what I'm going to do is I'm going to divide everything by 9. I'm doing that to get rid of this guy. So divide everything, 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 everything by 9 makes you go away. I have x plus 3 in parentheses squared over 9 plus y squared minus 10y equals negative 24. Now I'm still going to complete this process. Okay, where I have to take half the number in front of y, so negative 5, square that, which is 25, and add 25 to both sides. What that gives us is x plus 3 squared over 9. Now we can do perfect squares and make this y minus 5 squared, and look at God equals 1, which is kind of what we needed. Now the last thing that I'm going to do is I'm going to put this guy over 1. Now what we have is we have an ellipse. So let me put all the information about an ellipse up here. Now if you're like, how do you know that's an ellipse? Because that's a plus sign. If it was a minus, it would be a hyperbola. What's important about this ellipse is this number underneath x is larger than the number underneath y. So we're going to compare it to this version of an ellipse. So you have x minus h squared over a squared plus y minus k squared over b squared equals 1. And again, we use this version of the formula when this number is bigger than this number, which it is. Okay, now down here in the limited space that we have, we care about the center, we care about the vertices, and we care about the covertices. Okay, the center in these cases is going to be HK. The center in these cases, or the vertices rather, in these cases are going to be H plus or minus A, K. And then the covertices are going to be H, K plus or minus B. Now I have to identify what H, K, and A and B are. Okay, so let's go to the equation that we came up with. H minus, or x minus h matches up with x plus 3, which means h is negative 3. A squared matches up with 9, which means a is 3, square root. Y minus 5 matches up with y minus k, so k is regular 5. B squared matches up with 1, so b is 1. The center is HK, so the center is negative 3, 5. That's the center. The vertices are H and A plus or minus, H plus or minus A, K. So the vertices are going to be H plus A, so negative 3 plus negative 3, so negative 6, K, which is 5. Or the vertices could be H minus A, which is negative 3 minus 3, which is 0. I had that backwards. Doesn't matter. Okay, H minus would be negative 3 minus, negative 6. And plus would be plus. Okay, so I had that backwards. It's all right. I still come up with the same thing. My covertices, which I'm going to write here because I'm out of space, are going to be H, which is negative 3, K plus B, so 5 plus 1, and H, which is negative 3, K minus B, so 5 minus 1 is 4. So my center is negative 3, 5, so negative 3, 5. My vertices are negative 6, 5. So let me get a different color, negative 6, 5, and 0, 5. And my covertices are negative 3, 6, negative 3, 4. And we get an ellipse, which is like an oval. It's going to look like this. Wish me luck graphing these. I'm terrible at graphing things using this pen that I have, although I will pat myself on the back with this one. Okay, major axis, minor axis. Looks like an eye, the all-seeing eye, Lord of the Rings. But wasn't that awful? It was. Lots of fun, though. Write an equation of the circle below. All right, well, we have a circle not centered at the origin. So whenever we have a circle not centered at the origin, we're going to think x minus h squared plus y minus k squared equals r squared. My center is hk. So let's locate the center. Looks like you're going to be my center, which means my center in this case is going to be the point 1, negative 2. 1, negative 2, which means h is 1 and k is negative 2. So really showing my work because, this isn't that bad of a problem. We have x minus 1 squared plus y minus negative 2 squared equals the radius squared. Well, the radius is not that bad to find. Don't try to find the radius diagonally. Just count until you, up, down, left, or right until you hit the outside of the circle. 1, 2, 3, 4. So the radius is 4. So that equals 4 squared. Okay, so nothing changes in here. X minus 1 squared plus y plus 2 squared equals 16. And that, boys and girls, is the equation of a circle not centered at the origin. Great! Determine the equations of the asymptotes for the hyperbola defined by the equation 3x squared minus 16y squared minus 18x plus 32y plus 20 equals 0. All right. If you're looking at this and saying, that doesn't look like a hyperbola, you're absolutely right. Hyperbolas are supposed to look like something squared over something minus something squared over something equals 1. And that's not this at all. So this is what we have to do. We have to make it look like that. And this is the process that we do it. Group your x's first because that's just what we do. 9x squared minus 18x. Group your y's, so negative 16y squared, positive 32y. And let's subtract 20 from both sides, equals negative 20. Okay, now the first thing that we're going to do in order to make it look like a parentheses over a number or whatever is we're going to factor out the 9. So factor out the 9, that leaves you with x squared minus 2x. Okay, now what we're going to do is we're going to factor out the negative 16. That's where our negative comes from. So minus 16y squared minus, almost put a plus there, that was a close one, minus 2y equals negative 20. Now, I'm not where I need to be. I'm not at all where I need to be. So this is what I need to do. What I need to do is I need to, inside this parentheses, I need to kind of combine or complete the square rather. So what that usually looks like is I take a number, right? And I take the number in front of x, take half of it, so negative 1, square that, which is 1, and add that to both sides. So if I do that, okay, if I take half of negative 2, which is negative 1, square that, which is 1, and add that to both sides, I'm adding 9 to both sides. Why 9? Well, because inside the square root, or inside rather the parentheses, I'm adding 1. So if I were to distribute that, I would be adding 9. So I have to add 9 to both sides. Similarly over here, the same thing is going to happen. Minus 16, take half of the number in front of y, which is negative 1, square that, which is positive 1. And by doing that, minus 2y plus 1, I am subtracting 16 from both sides. Okay, so now what I get is sorry, I'm switching colors, 9x squared minus 2x plus 1 minus 16, y squared minus 2y plus 1 equals negative 36 plus 9 is negative 27. Now, here's the difficulty of this problem. Okay, this has to equal 1. So it's not a matter of getting rid of these guys and having like nothing in front of my parentheses. This has to equal 1. So let me quick do what I'm supposed to do here first. X minus 1 squared minus 16, y minus 1 squared equals negative 27. So what I have to do is I have to divide everything by negative 27. Everything by negative 27. Everything by negative 27. So that's good here because this becomes negative. Now I have to change things around. X minus 1 squared over 3. However, that doesn't happen here, okay, at all. In fact, there's no simplifying whatsoever. So what I do is I make this y minus 1 squared, and instead of 16 over 27, I have 27 over 16 on the bottom. I have the reciprocal. So ideal? No. But does it do the job? Yes. Yes, it does. And now it equals 1. So rewriting it now that I have a negative here and I have a positive here, I now have a hyperbola in the form y minus 1 squared over 27 over 16 minus x minus 1 squared over 3 equals 1. An equation where the y part comes first, then the minus sign happens, gives you vertical or slant asymptotes at y equals plus or minus a over b times x minus h plus k. Okay, now my a, b, h, and k are all found by looking at these guys. Okay, when it's the y first, it's y minus k, so k is 1. Okay, this is going to be my a. So a squared equals that, which means a, let's put it over here, is going to be the square root of that. So the square root of 27 over 16 is going to be 3 root 3 over 4. So that's a mess. So that's a. A equals that. H is going to be positive 1. So that's good news. And B is going to be the square root of 3. So y equals plus or minus a, which is the square root of 3 over 4 over the square root of 3, which is kind of good news, times x minus h, so x minus 1 plus 1. Now let's take this chunk over here. Let's erase this so I can give myself a little bit more space. Okay, in order to deal with 3 root 3 over 4, I have to multiply the top and the bottom. So I'll put that over 1. I'll multiply the top and the bottom by 1 over root 3, 1 over root 3, which means a lot of canceling out happens. Okay, so all of that's gone. And now I have 3/4. So my final answer is going to be y equals plus or minus 3/4 x minus 1 plus 1. And I'm not even going to consider splitting that up into two equations and do the positive version and the negative version because the whole thing is just a mess. But there you get it. It's awesome. Consider the parametric function f of t equals x of t, y of t, defined by x of t is 4 cos t, and y of t is 3 sine t. The graph of f is in the xy plane, which is the following shapes. Well, it's not a circle because if it was a circle, these numbers would be the same. Since these numbers are both positive and they're different, that's going to be an ellipse. Okay, basically you have as one x value is larger, like this would go out to 4 and -4. As it's spinning around, it's going to peak out at 3 and then come out at -4 and then come down to -3 and then blah, blah, blah. That's basically what you're getting at. Pretty standard for a parametric function. So there you have it, just an ellipse. Consider the parametric function f of t equals x of t, y of t, defined by x of t is 3 plus 1 over t, and y of t is defined as 2 plus 1 over t. Which of the following is an asymptote of the graph of f in the xy plane? Well, the way it works is in the xy plane, an asymptote occurs when the function x of t approaches a constant value as the limit approaches infinity. So if I were to take the limit as t approaches infinity of x of t, not y of t, x of t, of 3 plus 1 over t, basically what's going to happen is you know this from the very beginning of Unit 1. When you have 1 over t and you quote unquote plug in infinity, as t gets larger, like if I were to say t is 1, you get 1 over 1. If t is 10, then you get 0.1. Then if t was 100, then 0.01. As t gets larger, this guy right here, this whole thing approaches 0. So as the limit, as t approaches infinity, we are going to end up with just the number 3. So x is going to equal 3 is going to give us that asymptote that we need. Find the magnitude and direction of this vector, oh yeah, in component form, -8 and -41. First things first, what component form does is it gives you direction and it gives you distance. Okay, in order to draw a vertex in this form, you're going to have to go left 81. So you have like a starting point. You go left 8 because it's -8. And then you go down 41 because it's 41 and it's negative. And then your final vector is going to be from this starting point to where you ended up. So pretend that that's a perfectly straight line. We have a vector that goes down and to the left, much more down than to the left. So if you're looking at this and saying, this is like really familiar with some polar stuff and magnitudes and that, you're absolutely right. If I wanted to find the magnitude, that's basically the distance from here to here. That's basically Pythagorean theorem. So we would just say that the magnitude is going to be the square root of 8 squared plus -8, technically -8 squared, plus -41 squared. Now it will become positive, but I'm going to be specific. That's 64. This is 1681. Okay. And then when you add those guys together, you get the square root of 1745, which rounds out nicely to 41.773. Now, that is the magnitude. Okay, that is the distance. The absolute value from the beginning to the end is 41.773. In order to find the direction, it's basically like what we're used to. We're going to do the inverse tangent. Normally, we would do the inverse tangent of y over x. This is going to be absolutely no different. So the inverse tangent of negative 41 over negative 8. Okay, which requires the use of a calculator. So let me go off to the side and figure that out. All right, so this one you're looking at 4.52 radians. And 520 radians after you round everything together. So, you're looking at, so that's definitely like more than regular pi. So you are looking in this area right here. So it does make sense when you come up with these. But yeah, there you have it. Magnitude means distance from the very beginning. And the direction in this case comes from doing the stuff that we've been doing all year long. Sketch a graph of the vector, then find the magnitude and the direction of the angle. So what we have is something that's called unit vector form. It's very similar to component form. In this problem, component form would look just like this. Okay, so the things are basically the same. In order to draw this out, you're going to start at 0, 0. You're going to go right 5 units and then down 12 units. So I'm not going to be able to draw that. So let's make each of these units 3. So 3, 6, 9, 12, 15, negative 3, negative 6, negative 9, negative 12, negative 15. So basically go right 5, go down 12, and your vector is going to start here and hit perfectly down there if I knew how to draw a straight line. Now, what this means then is the magnitude, which is the same thing as the distance, can be found by using Pythagorean theorem or the stuff that we've been doing pretty much since Unit 3 by saying, all right, well, magnitude is going to be the square root of essentially my A value and my B value squared and added together. So 5 squared plus negative 12 squared. Okay, that's going to be 25. That's going to be 144. That's going to be 169. That's going to be 13. That's not in a square root. Okay, so the numbers here were friendly, no calculator needed. This one I am going to use a calculator for, even though this is not a calculator section. The direction part's not as friendly. Okay, the direction part is found by doing what we've been doing since trigonometry, and that's taking the tangent, the inverse tangent rather, of B over A. Okay, so in this case, B is negative 12, so inverse tangent of negative 12 over A, which is 5. So I'm not going to make believe that I can even do this in my head. I certainly can't. I don't know or think the numbers are friendly. This isn't a 30, 60, 90 or a 45, 45, 90. So I'm going to go off to the side and figure out what this is. All right, so according to Mr. Calculator, this is negative 1.176. But I don't like that. So if I add 2 pi to it, which I'm doing right now, I get 5.107 radians. Which, 2 pi is like 3.14, so it's 6.28. So this is definitely just below the 2 pi mark. But yeah, not too close to it. So yeah, there you have it. It all makes sense. All right, so we have 2 vectors in component form, and we are asked to find 4 times the one minus 6 times the other. The nice thing about vectors in component form is the math is exactly what it looks like. But what this means is if I were to draw 4 Fs, and the way you would draw 4 Fs is like, you would go right 12 up 2, and then do another one, and then do another one, and then do another one. Right? And then go in the opposite direction to draw 6 V's. So it would be like left 2, down 4, left 2, down 4, left 2, down 4. I'm not even going to try to draw it out. But it would look something like this. So even though I said I wouldn't do it, I'm doing it anyway. You're going to end up here. So what's the distance from the very beginning to where I ended? That's what I'm doing with these guys. And like I said, the math is exactly the way it looks. You do 4 times the vector, 12, 2, and then you're going to subtract out 6 times the vector, 2, 4. Okay, so kind of like distributive property, you end up with 48, 8, which makes sense. If I'm going to go right 12 up 2, right 12 up 2, right 12 up 2, I'm going to end up going right 48 up 8. And I don't know why I made you a parentheses, but I did. And then we're going to add on top of that, I'm going to multiply negative 6 to both of these. So negative 12, negative 24. So the picture that I drew is way off. That's all right. That's okay. It's the heart that's there. You become 36. If I add what appears to be the x values or the left-right values of the vertex, and then you add these guys, which ends up being negative 16, that's going to be my guy. So again, the picture that I drew was way off. I probably shouldn't have made these look like that. I should have made these look more like that. Something like that. That probably would be a lot more accurate. But again, it's the thought that counts in math. That's always the case. Like and subscribe. Find the dot product of the given vectors. If you're given 2 vectors in 2-dimensional space, finding the dot product, if it's already in component form, is actually really nice. You multiply the x values, the lefty-righty values, so 3 times 6. You multiply the y values, so the uppy-downy values, 9 times 5, and then you add those 2 products up. So this would be 18 plus 45, which is going to be 63. So there you have it. Consider a vector v in 2-dimensional space in component form negative 2, 5. Determine the unit vector in the same direction as v expressed in component form. Now, unit vector is a vector with magnitude 1. And the way you find the unit vector, which is given to you as like a vector with a little hat-looking thing, is you take the vector that you're given and divide it by the magnitude of the vector. Now, the magnitude is the absolute value, is the direction. So we have the vector, so that's good news. What I need to do is I need to find the magnitude of this, and we do that by doing basically the Pythagorean theorem. So the magnitude is going to be the big square root of negative 2 squared plus 5 squared. Okay, negative 2 squared is 4, 5 squared is 25. So that is going to be the square root of 29. Obviously, I don't need to go much further than that. So what I'm going to do is I'm going to take my vector, which was negative 2, 5, and I'm going to divide both of the things on the inside by the square root of 27, which ends up being my unit vector is going to be negative 2 over the square root of 29 and 5 over the square root of 29. And for some reason, this problem isn't making me rationalize this, which, hey, I'm not going to complain about that at all. I hate doing that. But there you go. The answer is going to be A. A particle moves in the xy plane according to the vector-valued function r of t equals 3t 2t squared. Find the position vector of the particle at t equals 2. Well, basically, in order to find the position of what this particle is, and of course, there's basically, it's almost very much like a parametric function. I'm going to take 2 and I'm going to plug it into both of these guys. So r of 2 is going to equal 3 times 2 in component form and 2 times 2 squared. It's going to end up being 6. That's going to end up being 4 times 2 is 8. And there you have it. So whatever this means, you're given some kind of vector that, goes like this or something like that. And after 2 seconds or whatever, you're right here, and that right here represents right 6, up 8. Fun stuff. A particle moves in the xy plane with position vector r of t equals, in component form, 2 cos t, 3 sine t. Determine the distance of the particle from the origin at t equals pi over 4. Well, basically, we know what distance looks like. It's the magnitude. So, like, the magnitude of r at pi over 4 is going to be found by doing Pythagorean theorem. All right, so something that we're very much used to. It's going to be r of, I guess we'll do the a version. So, like, I'll just write it out like this: a squared plus b squared. I don't want to overcomplicate anything. Where in this case, a squared is going to be 2 cos t, which is pi over 4. Close it, squared. Plus 3 sine, in parentheses, 3 sine t, which is pi over 4 again, close it, squared. And let's scooch you over. Now, cosine of pi over 4 is root 2 over 2. So we have 2 times root 2 over 2. So just root 2, all right, squared, plus 3 sine of pi over 4 is also root 2 over 2. So nothing cute fancy happening here. It's going to be 3 root 2 over 2 squared. All right, I'm going to need the space. Not so much for the left one, but for the right one. That just gives us 2. Root 2 squared is 2. Okay, let's do 3 times 3 is 9. Root 2 times root 2 is 2. And then 2 times 2 is 4. So 18 over 4. That's going to equal the square root of 2 plus 9 over 2, which is just going to end up being, what, 13 over 2? Square root of 13 over 2? So, yeah, not the prettiest thing in the world. So, but, there you have it. We did it. Simplify this 2 by 2 matrix multiplied to this 2 by 3 matrix. Now, in order to make sure you can do this, you have to make sure that you can do this. Where did I get 2 by 2 from? There's 2 rows, this guy and that guy, and 2 columns up and down. This guy has 2 rows, left, right, and 1, 2, 3 columns up and down. In order for you to be able to do it, you have to have the number of columns of the first matrix and the number of rows in the second matrix be the same exact number, and they are. The resultant matrix is going to end up being the outside numbers, a 2 by 3 matrix. So we are able to do this, and this is what we do. Split the first matrix up by rows and the second matrix up by columns. Okay, now I will show all of my work for this one. I'm not going to guarantee that I'm going to show all of my work for every single matrix problem that I do, but I am for this one. So we are going to end up with a 2-row matrix, right? 3-column matrix. Now what you do is you multiply elements of the corresponding row-column combination. In other words, this first guy, I'm going to end up with a 2 by 3. So I'm looking at row 1, column 1. Up here, I'm going to look at row 1, column 1. Each row and each column have 2 elements in it. So I'm going to multiply the first element in each one, then plus multiply the second element in each one. So 3 times 2 plus negative 3 times 6. First row, second column, first row, second column. 3 times 6 plus negative 3 times negative 5. 3 times 6 plus negative 3 times negative 5. first row, last column, first row, last column. First element 3 times 1 plus -3 times 4. Okay, now we're done with the first row. We repeat the process with the second row. Okay, second row, first column, second row, first column. First element is 6 and 2, so 6 times 2 plus, I don't know why I have double parentheses there, 3 times 6. It's my daughter screaming in the background. Hopefully you didn't hear that. Maybe you did. Otherwise, you're going to think I'm crazy. Probably too late for that, though. Second row, second column, 6 times 6 plus 3 times -5. Then you have 6 times 1 plus 3 times 4. Okay, now it's just a matter of you doing some math and tons of it. So, see if I have enough space. 6 plus negative, so -18. Okay, so let me continue with the dashes. Let me continue with the dashes until I'm completely done. 18 plus 15, 18, 15, 3 minus 12, 12 plus 18, 36 minus 15, 6 plus 12. Now to complete this sucker, 6 minus 18 is -12. 18 plus 15 is 33. 3 minus 12 is -9. 12 plus 18 is 30. 36 minus 15 is 21. And 6 plus 12 is 18. And that, boys and girls, is how you multiply a 2 by 2 to a 2 by 3. Fun! Simplify this, what is that, a 4 by 2 matrix multiplied to a 2 by 2 matrix multiplied to a 2 by 2 matrix. Now, the order in which you multiply matrices is 1,000% important. We always go left to right no matter what. When you're multiplying two matrices together, it's very important that if you multiply this guy to that guy, that the number of columns in the first matrix matches up with the number of columns in the second matrix, which it does. Sorry, the number of rows in the second matrix, not the number of columns, the number of rows in the second matrix, which it does. So 4 by 2 does multiply to a 2 by 2. It's defined, and you're going to end up getting a 4 by 2. So let's worry about that, and we'll do the 2 by 2 when we're done. Now, in a previous example, I showed all of my steps. I'm not going to go super crazy showing all of my steps just because I'm going to need the space. I mean, I'm going to end up with a 4 by 2, and I'm definitely going to need the space. So what you do is you take your first matrix, split it up by columns, split it up by rows, I mean. You take your second matrix, split it up by columns. Now, when you apply the matrix multiplication, what you do is you are looking at this guy, first row, first column, and you're going to look at this guy, first row, first column, and you're going to multiply the first two elements. So 3 times 0 is 0, and then you add, you multiplying the second two elements. So 2 times 2 is 4. Then you repeat the process. First row, second column. 3 times 0 is 0. 2 times -6 is -12. Okay, second row, first column, 2 times 0 is 0. 1 times 2 is 2. Second row, second column, 2 times 0 is 0. 1 times -6 is -6. Third row, first column, 3 times 0 is 0. 4 times 2 is 8. Third row, second column, 3 times 0 is 0. 4 times negative 6 is negative 24. Ugh. Negative 1, so last row, first column, negative 1 times 0 is 0. Negative 1 times 2 is minus 2. And then last but not least, fourth row, second column, negative 1 times 0 is 0. Negative 1 times negative 6 is plus 6. Then we simplify this guy. So we get 4, we get 2, we get 8, we get negative 2, and then we get negative 12, negative 6, negative 24, positive 6. Now we can multiply this matrix. So we have a 4 by 2 again, a 4 by 2 again. We are multiplying to a 2 by 2. So again, we're allowed to do this. Thank goodness for all these zeros. That's going to make life so easy. So we're allowed to do this, and we'll end up with a 4 by 2 again. Okay, so I think that should be enough space. It was last time. You split the first matrix up by rows, the second matrix up by columns, and then you do exactly what we did up here. 4 times negative 2 is negative 8. Negative 12 times 0 is 0. Okay, first row, second column. 4 times 6 is 24. Negative 12 times 0 is 0. Second row, first column. 2 times negative 2 is negative 4. Negative 6 times 0 is 0. Second row, second column. 2 times 6 is 12. Negative 6 times 0 is 0. Third row, first columns. 8 times negative 2 is negative 16. 24 times 0 is 0. Third row, second column. 8 times 6 is 48. 24 times 0 is 0. Last row, first column, negative 2 times negative 2 is 4. 6 times 0 is 0. And then last but not least, last row, last column, negative 2 times 6 is negative 12, and 6 times 0 is 0. Then you add them up, add them up, add them up. Lots of zeros. So basically, you just negative 8, negative 4, negative 16, 4, 24, 12, 48, negative 12. Thanks for watching. Simplify letters. Well, we have ourselves a 2 by 3 matrix that we're multiplying to a 3 by 2 matrix. Okay, 2 rows, 3 columns, 3 rows, 2 columns. This will be defined because the inside numbers are the same, and we'll end up getting a 2 by 2. So that's what we're going to get, a 2 by 2 where stuff really isn't going to combine, maybe at all. So I'm going to make this a big matrix, and if it's too big, then it's too big. I'm going to split this up. I'm going to split this up, and I'm sure that's plenty of room. But what we do is we take the first matrix, split it up by the row, and try to not cut anything in half. And then you take the second matrix, split it up by columns, like that, much better. Okay, now we have 3 elements in each row column combination. So we multiply the first element plus, multiply the second elements plus, multiply the third elements plus. So 6u times negative 3u is negative 18u squared plus 2u and 6u is 12u squared, so these do combine, plus u squared and negative 6u is going to be negative 6u cubed. So a little bit of combining is going to happen, so we're not done yet. We're not in the clear. All right. First row, second column. 6u times 1, 6u. 2u times 3v is going to be plus 6uv. And u squared times v is going to be plus u squared v. No combining there. Second row, first column, uv times negative 3u is going to be negative 3u squared v. v squared times 6uv is going to be 6uv squared. Negative 2 times negative 6u, negative 2v squared times negative 6u is going to be plus 12uv squared. A little bit of combining. uv times 1 is uv. V squared times 3v is plus 3v squared, cubed. Negative 2 times v squared times v is going to be negative 2 times v cubed. So all it is now is just combining like terms in each row / column. All right. So these two combine to make negative 6u squared minus 6, was that u to the third? U to the third. Okay, might have to scooch this over just a little bit to give myself plenty of space. And I'll do different colors to make sure that this is clear. None of these combine, so 6u plus 6uv plus u squared v. Negative 3u squared v combines with none of them. But the 6uv squared and the 12uv squared make 18uv squared. And then we have uv, which combines with nothing. And we have 3v cubed minus 2v cubed is regular 1v cubed. Ooh. Consider two matrices A and B, where A is 3 by 2 and B is 2 by 4. Which of the following statements is true regarding the product AB? All right, well, if A is a 3 by 2, right, and if B is a 2 by 4, without looking at my options, this is allowed. You will get something that's defined because the inner two numbers are exactly the same. And what you'll get at the end is 3 by 4. So the product AB is defined. Yep. The product AB is undefined. Nope. The product AB is a 2 by 2. Nope. And the product AB is a 3 by 4. Yup. So A and D are true. They are both correct in this case, which is, one of those weird ones where it asks which are the following statements is true. We have two statements that are true, and it's going to be A and D. Evaluate the determinant of this 2 by 2 matrix. If you're given a matrix that looks like this, 2 by 2 standard, and you're being asked to find the determinant of that, it's actually pretty simple. You just take A times D, so the top left times the top right, minus the top right times the bottom left. So BC. So in this case, the determinant is going to be negative 4 times negative 3 minus 4 times negative 5. So we're looking at 12 plus 20 is 32. So that's your determinant. And basically what the determinant does is lets you know if you can take the inverse matrix. And if you couldn't take the inverse matrix, your determinant would be 0. Well, our determinant's 32, so we could take the inverse of whatever matrix this is. And if you're like, what's the inverse? Next video, and you'll find out. Find the inverse matrix of negative 3, negative 3, negative 4, negative 3. So the inverse matrix is found by taking 1 over, and let's just call this A, 1 over the determinant of A times the matrix found by taking A and B, or A and D, and swapping them. So your bottom right and your top left swap. Your top right take the opposite of, and your bottom left take the opposite of that. So what we need to do first is we need to find the determinant. Then once we find the determinant, that will let us know if we could even take the inverse. So let's do that. The determinant is found by multiplying u times u, the top left and the bottom right, so negative 3 times negative 3, and then subtracting u times u, So negative 3 times negative 4. Okay, so 9 minus 12 is negative 3. Now, the determinant is negative 3, which means, yes, we could take the inverse of this matrix. The only time we couldn't take the inverse of the matrix is if the determinant is 0, because you would get 1 over 0, which is undefined. That's impossible. Now what I need to do is I need to take 1 over negative 3 and multiply it to this matrix rearranged. So let me get a different color and write out 1 over negative 3, so negative 1/3, times swap the A and the D, which does absolutely nothing. Make negative 3 positive because it's the opposite, so positive. You become positive 4 because you take the opposite of the bottom left number, and then you just do scalar multiplication, which means you take that negative 1/3 and multiply it to every element in here as if it was distributed property. So negative 1/3 times negative 3 is positive 1. Negative 1/3 times negative 3 is negative 1. Negative 1/3 times positive 4 is negative 4/3. And negative 1/3 times negative 3 again is positive 1. And that's your inverse matrix. Given the vertices of a triangle ABC, where A is 1, 2, B is 4, 6, C is 5, 3, what is the area of a triangle? So we're living in quadrant 1. 1, 2 is like here. We'll call you A, and B is 4, 6, so we'll call you B, and then C is 5, 3, we'll call you C. And our job is to find the area contained in this triangle that I am drawing terribly, so if I just do this, no one will ever know that I can't draw worth a lick on this computer. So we're trying to find the area of this triangle right here. Perfect. Now what we can do is we can use the area using cross products. Okay, so half of a vector and a vector multiplied together using cross products. Now what we need to do is we need to take two of these sides and we need to turn them into vectors. Well, how do we do that, and what are we going to do? Well, let's choose sides A, B to start out, and then we'll figure out what we want to do. The way we find out a vector for AB is and we'll call this V little a little b, because why not, so that when we do this, maybe we could have called it U, but it's too late now and you can't stop me. We're going to take the X value, and we're doing AB, so we'll call you X sub 1, Y sub 1, X sub 2, Y sub 2. I'll probably eventually end up erasing that. It's very, 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 very similar to like slope formula stuff or distance formula stuff, where you end up with the one X value minus the other. So X sub 2 minus X sub 1. So 4 minus 1, which is 3. And Y sub 2 minus Y sub 1. So 6 minus 2, which is 4. Okay, so there's one of our sides written out as a vector. Now let me erase this because I'm probably going to need to rewrite things, and let me choose a different color. Let's choose side AC because why not? I'll call you vector AC, and it's basically going to be the same thing. I'll pick A, call you X sub 1, Y sub 1. I'll pick C and call you X sub 2, Y sub 2. So the X part of the vector AC is going to be X sub 2 minus X sub 1, which is 4. Y sub 2 minus Y sub 1, which is 1. So now I have my two vectors. Okay, now the way I do cross products is I'm basically going to do what's, in a sense, a matrix. Okay, so let me write it out as a matrix, because why not? I have my one vector, which is going to be 3, 4. I have another vector, which is going to be 4, 1. Okay, and the way I do vector multiplication is I essentially take the determinant, which is going to be 3 times 1, 3, minus 4 times 4, which is 16, and that's going to end up being negative 13. Okay. Now what I do in order to do cross products is I have to take the absolute value of that, which is going to be the absolute value of negative 13, which is going to be positive 13. All right, so now to complete this, I have to do, and by the way, what I just did here was this part. Now I have to take 1/2 of that, and 1/2 of 13 is 6.5. So, yeah, there you go. That's the area of a triangle using cross products. Not that much fun. Solve a matrix minus a matrix times some matrix B equals a matrix. Well, the way I'm going to start this problem out is the way I would start out any two-step equation. Subtract the thing that's floating around. So I'm going to subtract this matrix that's floating around. I'm going to subtract negative 3, 7 from both sides. I am allowed to do that because on the right side I have a 2 by 1, and a 2 by 1 minus a 2 by 1 is perfectly legit. Pure legitness. So I can cross you out. Now what I'm left with, and I'm going to need all the space I can, is negative 3, 0, 5, 1 times matrix B is going to equal 21 minus negative 3, which is 21 plus 3, which is 24, and negative 39 minus 7, which is negative 46. All right. Now, before I go any further, that negative is just being a pain in the butt. Let's get rid of it. Let's multiply both sides by a negative, so that essentially gets rid of the negative on the left, leaving me with just the matrix on the left, and times B, of course. Can't forget that, times B. And that's going to equal negative 24, positive 46. Now, the rule is, if you have a matrix times a matrix equals a matrix, you can write it out as A times B equals X. The way you solve it is you essentially take the inverse matrix on the left side of both sides, that crosses out, and B times A inverse X is going to be your answer. So what I need to do is I need to find the inverse of that guy right there, so I can do the inverse times this guy and get my B. All right, so let's erase all of this, and let's go off to the side and find the inverse of B, or of A rather. Okay, so I'll call you A. You're now A. The inverse of A is going to be 1 over the determinant. What's the determinant? AD minus BC. So AD minus BC multiplied to you flip-flopping the A and the D elements, and then you swapping the signs of B and C. So what that's going to look like for us, A inverse, is going to be 1 over A times D, which is negative 3, minus BC, which is 0 times 5. Well, that's good news. You I forgot to do it. You flip-flopping the A and the D, perfect, is going to look like 1 and negative 3. And then you making the B and C negative is not going to do anything to 0, but it's going to make that 5 negative 5. All right, so just to save some space, negative 3 minus 0 is just negative 3. So I have 1 over negative 3, like that, or negative 1 over 3, however you want to view it. So the A inverse is going to equal negative 1/3, 0, positive 5/3, 1. So B is going to be me multiplying negative 1/3, 0, 5/3, 1 to negative 24 and 46. Okay, we have ourselves a 2 by 2 being multiplied to a 2 by 1. So this is legal. And we're going to get ourselves a 2 by 1. So 2 rows, 1 column. Okay, negative 1/3 times negative 24 is basically the same thing as saying positive 24 divided by 3, which is 8. So I should split that to make it look better. Plus 0. That's good news. So let's scooch you over. 5/3 times negative 24 is essentially saying negative 24 divided by 3, which is 8. Negative 8 times 5 is negative 40 plus 46. So at the end of the day, B is going to equal 8, 6. And what that means is if I were to multiply U to 8, 6 and then make it negative and then add negative 3 over 7, I get 21 over negative 39. Awful, but I did it. You are given 3 vectors in two-dimensional space. That's what that means. Vector 1 is 1, 2. Vector 2 is negative 1, 3. And vector 3 is 4, 0. Create a 2x3 matrix A using these vectors as its columns. This is going to be the easiest problem I will ever do. So vector 1 is 1, 2. Vector 2 is going to be negative 1, 3. And vector 3 is going to be 4, 0. Well, thank you, everybody, for watching. I hope you had a good time. Like and subscribe. L is a linear transformation function of vectors given by that equals that. Basically, A times the vector matrix. So this would be my A. This would be my vector matrix. It tells me that right there. 3 vectors with the A's, with the B's, and with the C's are mapped below. So A's, B's, C's, okay, very good, are mapped with the function L, and the following results are given as such. Determine that plus that plus that. So this is what I'm going to do. I'm going to multiply these 2 matrices together like so, like usual, and then simplify whatever I can and set that equal to that and see if I can figure stuff out. Okay, so I'm multiplying a 2 by 2 to a 2 by 3, which is legal, and I'll end up getting a 2 by 3. So I'll end up getting a 2 rows, 3 columns. Let me split those up. Okay, 1 times a sub x is a sub x. 2 times a sub y is 2 times a sub y. Boom. 1 times b sub x is b sub x. 2 times b sub y is 2 times b sub y. Boom. 1 times c sub x is c sub x. 2 times c sub y is 2 times c sub y. All right. 3 times a sub x is 3a sub x plus 4 times a sub y is 4 times a sub y. 3 times b sub x is 3b sub x plus 4 times b sub y is 4b sub y. And then 3 times c sub x is 3c sub x plus 4 times c sub y is 4c sub y. My job is to find out what AB, or rather AX plus BX plus CX is. So what I'm going to do is I have 3 systems of equations that I guess I'm going to do. Holy cow. I guess I have a sub x plus 2a sub y is going to equal 1, because the top left up here is going to match the top left up here. So u, since these 2 are multiplied together, equal 1. Okay, 3a sub x plus 4a sub y, the bottom left, row 2, column 1, is going to map to 1. And so now it's a systems of equations type problem. So if we want to do elimination, well, what I really want to do is find out what x is. So yeah, let's do elimination. Let's multiply the top row by negative 2. And what that does is that's going to give us, I'll write it down here to make life easy. That's going to give us negative 2a sub x minus 4a sub y equals negative 2. Okay, when you do elimination, you add these two rows together. That crosses out. So I set this up on purpose so that I would get a sub x. A sub x with nothing in front of it is going to equal -1. So a sub x is going to equal -1. And then we do it again. We'll set up a system of equations with the two numbers in the middle here with the middle column. So we have b sub x plus 2 a sub y is going to equal -2 because it's the top row middle column. Okay, that's going to match up with 3b sub x plus 4b sub y equals also -2. Again, my point is to find b sub x, so what I'm going to do is I'm going to multiply the top row again by -2, and what that'll give me is -2b sub x and 3b sub x, and that'll get me b sub x. So your -2b sub x, your -4b sub y, and you're going to become +4. So that when I add these two guys together, I have regular b sub x, you go away, equals 2. So you are 2. One more system of equations. What a terrible problem. C sub x plus 2, I already did the 2, C sub y is going to equal 7. And then 3c sub x plus 4c sub y is going to equal 15. Again, my job is to get c sub x, so I'll multiply the top row by -2 because that'll just get me c sub x. So -2 c sub x minus 4 c sub y equals -14. You cross out, you become 1 c sub x is going to equal 1. So you're 1. So a sub x, which is -1, plus b sub x, which is regular 2, plus c sub x, which is regular 1. Oh boy, I almost screwed the whole thing up. Regular 1 crosses out, and you get 2. So very difficult, very challenging problem. Makes you think outside the box. The box. It's a matrix. It's fun. We have fun here. Like and subscribe. Solve using matrices. All right, so this is how I can rewrite this as a matrix. I can take the coefficients 5, -4 for the top row, invisible 1 for the bottom row, multiply that to a matrix of x and y, and that will equal what I get over here, -10 and 2. Now, this is basically following that rule that if you watch all of my videos in order, which I pray that you do, if you have something like this where you're trying to find matrix B, so like a matrix times a matrix equals a matrix times a matrix equals a matrix, you inverse A to the left side of both sides, which allows that to cross out. And so what you need to find B is you need B equals the inverse of A times X. So what I need to do is I need to call you A and find the inverse of it. So the inverse is found by taking 1 over the determinant, which is AD minus BC, and you're going to multiply that to the matrix where A and D are flip-flopped and B and C are opposite. So the inverse of A is going to be 1 over A times D, which is 5 times 1, minus B times C, which is -4 times 1. Thankfully, we get 1. D is going to be 1. A is going to be 5. -4 is going to be 4. -1 is going to be 1. So 1 times 1, 4, 1, 5 is just 1, 4, 1, 5. So my inverse matrix is that guy right there. So XY is going to be my inverse matrix times X. So 1, 4, 1, 5 times this guy, negative 10, 2. Okay, split this up. X, y is going to equal 1 times negative 10. So what is this, a 2 by 2? We're multiplying that to a 2 by 1, so we'll get a 2 by 1 when we're done, so a 2 by 1. So 1 times negative 10 plus 4 times 8, 1 times negative 10 plus 5 times 2 is going to end up giving us negative 2, 0. So x equals negative 2, y equals 0. And that's how you can solve a system of equations using matrices. Isn't that neat? L is a linear transformation function of vectors given by L of vector v equals A times vector v, where A is a 2 by 2 matrix. I vector is in component form 1, 0. The vector j is component form 0, 1. They are standard unit vectors in two-dimensional space. A times vector I is the matrix 0, 1, and A times vector j is the matrix 1, 0. Determine L of a vector in component form negative 2, 3. Okay. Well, that's component form, and if I wanted to, I can write it out in unit form as 2 times vector I plus 3 times vector j. Okay, if I wanted to do that. I just found out that I is 0, 1. So if I wanted to, I can do negative 2 times 0, 1 plus 3 times 1, 0. Okay, which this is just scalar multiplication. So negative 2 times 0 is negative 2 times, just kidding, it's 0. I don't know why I said that. Maybe I was looking ahead. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Plus 3 times 1 is 3. 3 times 0 is 0. And we end up with 0 plus 3 is 3. Negative 2 plus 0 is 0. 2. Negative 2. Whew. Negative 2. Now, what this means is we now have a vector in component form that looks like 3, negative 2. So it's a very bizarre problem. Very bizarre problem, but that turns into that. Consider a triangle ABC with vertices 0, 0, 4, 1, and 8, 2 in the xy plane. Each vertex can be represented as a column vector in a 2 by 3 matrix. So if I wanted to, I can write that out right now as 0, 0, 4, 1, 8, 2. Now envision a transformation that maps a point xy to negative x, negative y, which is basically just flip-flop everything. I mean, if x and y's become its opposite, so negative 0, negative 0, negative 4, negative 1, negative 8, negative 2. So not only did I envision it, but I did it. The transformation effectively mirrors the points across the origin. When applied to the vertices of a triangle, this transformation results in a rotation of pi radians counterclockwise about the origin. Okay, I can see it. I can see it. This rotation essentially flips the triangle over to the opposite side of the origin while preserving its shape. Yes, that's what a rotation means. Which of the following options gives the image vertices as a matrix of column vectors? Isn't it just B? So all that reading just for that? All right, guys. Well, thanks for watching. Like and subscribe. Consider a scenario in which the likelihood that an object is in state A or not in state A is known. So I guess state, I don't know, state of the union? The likelihood that the object stays in its current state or moves to the opposite state is also known. Which of the following matrices could be a transition matrix from the current state of the object to the next state of the object? All right, so we're given three matrices, and this is like those probability matrices where if you add up the left number to the right number, it has to equal 1. So that's what we're doing here. Is the number on the left plus the number on the right equal to 1? Well, you're not, because you're going to be like 0.85, so 1 is no good. 0.6 plus 0.4 is 1. 0.25 plus 0.75 is 1. I don't care about the columns. That has nothing to do with anything. That's good, that's good, that's good, that's good. 0.8 plus 0 is not 1 again. I think they tried to trick you here where they gave you the columns that do add up to 1, but I don't care about the columns. Don't care at all. All I care about is, do these left and right numbers add up to 1? Yes, yes. So the answer is 2 and only 2. Or I, like my last name. Consider a scenario in which an object in either state A or not in state A. The likelihood that an object stays in its current state or moves to the opposite state is shown in the transition matrix, so right there. After an object has gone through one transition, its state vector is that guy right there. So U. What is the probability that the object was initially in state A? So basically, we can represent this transition with this matrix times this matrix equals this matrix. So we have 0.1, 0.7, 0.9, 0.3. Okay, I'm going to multiply that to xy, and that's going to equal 0.56. and 0.42. Now, this is one of those situations where A and, like, I'm giving something that looks like this. A times B equals X. And so what I need to do is I need to inverse A, multiply it to both left sides so that crosses out, and then B equals A inverse X. So since I'm allowed to use a calculator for this one, that's exactly what I'm going to do. I'm going to run to my calculator. I'm going to call you A, and you are now X, and I'm going to find out what A inverse times X is going to equal, and that will help me come up with an answer. All right, so I'm doing A inverse times X. So what I'm going to do is I'm going to create an inverse called A by doing second matrix, and I'm going to edit A. A is a 2 by 2 matrix, and we were given 0.1, enter, 0.7, enter, 0.9, enter, and then 0.3, enter. Now that I have this done, I'm going to quit out, and I'm going to create a new matrix to represent my X matrix. So I'm going to second matrix, and let's just call X C or D. I'm already at D, so let's edit D. Let's edit D. Why not? That matrix was a 2 by 1, so a 2 by 1, and that matrix was 0.58, enter, and 0.42, enter. Now what I need to do, and let's quit out of this, is I need to find A inverse D. So go to second matrix, select A, and we're going to do the inverse button, which is U. We're going to multiply this to second matrix 4. Hit enter, and we get the points 0.2 and 0.8. So let's go back and see what that means. Okay, so when we initially created this problem, the X and the Y, X meant the probability that it would stay in state A, and Y would be the probability that the object would not be in state A. we ended up getting the matrix 0.2, 0.8. Now, the probability that the object was initially in state A has to do with x. So x being 0.2, which means the probability was 20% of the object being in state A. So, tricky problem, very difficult, but we did it.